This is our media prep lab. What we're doing in here is both testing the media that the algae are in, looking at how well they grow, providing nutrient mixtures. What you see here on the left, Seth, is actually doing an optical density test of the algae. That's a fairly quick way of looking to see how the algae grows by testing the differential optical density. What you're looking for there is they grow thicker and thicker, they get darker, and light has a harder time passing through. So you measure that here, and that'll give you a measure of growth. Fawn here, who is one of our lead scientists, is actually doing pH testing. It's important with algae to control the pH because if it's too acidic, it's harmful, and likewise, if it's too basic, that is, the pH gets too high, it can be harmful for the algae as well. So we do these kind of tests in this lab, which is very, very helpful to fine-tuning the way you cultivate algae at large scale.
Before the algae are placed in the bioreactors at the Red Hawk Engineering Scale Pilot, they are first cultivated in large inoculation bags. Here they are continually monitored for quality and consistency before they are introduced into the functional systems. Quality control is an extremely important part of the process, as contaminants or other predator species could play havoc with productivity if they are inadvertently introduced to the existing cultures.
Every now and then it's useful to actually go look at the algae. These are microscopic, so you need microscopes to see them. One reason we look at them under the microscope is to count them. It's another way to corroborate the growth rates that you're getting. Jennifer, one of our young scientists, is looking at a specimen right here. Another reason you want to look at them under the microscope is occasionally predators get in and they will actually eat the algae. I don't think we have any of that here, but you can get a view of the algae under the microscope. It's very interesting sometimes to see a big rotifer that you can see through and to see a lot of our algae in his stomach are really absorbed by him.
The inoculation bags are inspected several times a day for adaptation to local sunlight. But a lot of this testing begins at the lab back in Cambridge, Massachusetts.
What we're measuring here is fluorescence. Whenever you shine a light on the algae or if it receives sunlight, the algae actually gives off a light which is called fluorescence. So what this probe does is it shines the light onto the algae. And when it does that, the algae sends another light back. And that's a very quick and easy way of measuring growth and health of our algae. Our algae is very healthy. It's doing very well.
Can we slow global warming? Can we replace fossil fuels with clean, renewable alternatives? The extraordinary potential of algae systems to recycle large volumes of CO2 into biodiesel and ethanol could be the answer. Now there's some fuel for thought.